Good afternoon, ladies and gentlemen. Welcome to the Energy from Waste Theatre 2 o'clock session. I'd like to thank RWM for inviting me back this year again to present on activated carbon. My presentation this afternoon is a broad introduction to activated carbon purification and how we help customers solve their purification challenges, with a particular focus on the waste management industry, which I think is the most relevant to the audience today. My name is David Reay and I work for CPL Activated Carbons. So I normally start these presentations by saying what activated carbon actually is. We know from our experience there's quite a lot of confusion what carbon is and what it isn't. So I'll give a quick introduction about what it is, this filtration medium that we're talking about, and say where you're likely to find it, particularly in the waste management industry. I'll talk about other sectors too. So what is it and what is it used for, to set the bar for the rest of the presentation. I'll introduce my company, CPL Activated Carbons, and I'll talk about the broad range of services that we offer in terms of carbons, in terms of vessels, reactivation or recycling of spent material, and the site services element as well. I'd like to go into more detail on the reactivation or the recycling of spent carbon, because that's a key unique selling point that we have, and it's a key area where we've invested a lot of money over the years, and we believe it is the future for our industry. Recycle what you've got rather than use new stuff again. Talk about the two different main streams. There's the green list stream, which is essentially waste carbon from drinking water facilities and food, and then the amber list stream, which is everything else, environmental and industrial, biogas, odor control, VOC, wastewater, remediation, all those things. And we have two separate streams for those two types of carbon. Talk about the benefits and also some recent advances. We're constantly moving the bar and trying to improve the process and the efficiency. I'm inserted a slide towards the end on future market developments. So a lot of our business is driven by clean water, clean air, legislation, renewable energy, and that always changes. It's a moving target. So I wanted to share with you one slide where I see the market going in terms of purification, and then a summary at the end. What is activated carbon? It's basically a very pure form of charcoal with a very high surface area. How high? Well, typically we say that a gram of activated carbon, so a teaspoonful, has about the surface area of a football pitch. So it's typically 900 to 1,000 square meters per gram of materials. And it's that vast surface area which makes it attractive as a filtration medium. It's made from various raw materials. They're very specific to give you the carbon quality that you require. Most carbon in the market is either coal-based bituminous or anthracite coal. Coconut shell forms very good hard carbon as well. Some types of wood form good carbon for particular applications. I've written biomass there as well. We have R&D programs looking at alternative raw materials, perhaps more sustainable raw materials. But essentially, as we stand today, the market is driven mainly by coal-based carbons, plus, to a lesser extent, coconut and wood. Now, activated carbon has a vast internal pore structure made up of pores, and you can see the micrograph on the right-hand side. Those pores vary enormously in terms of size, ratio, and quantity, depending on the raw material that you've chosen, how it's been activated, how long it's been activated for. And you can basically understand that if you pass a fluid, a gas or a liquid through a bed containing that material, those impurities will be trapped in those pores, and that's why it's such a good purification medium. That is a reversible process, generally speaking. So you can imagine you apply heat to the spent carbon, you can drive those impurities out of those pores to basically recycle the carbon. And that's why we've invested so much in a reactivation system up at our factory in Immingham. The process of impurities going into the pores is called adsorption with a D. It's different from absorption with a B, where you think about the sponge absorbing water throughout its entirety. Adsorption is all about the surface activity. It's just a niche term that we use in our industry. So a standard activated carbon is ideal for filtering organic impurities. And what do I mean by that? Well, in your industries, typically you'll come across VOCs or volatile organic compounds. In biogas, you come across siloxanes. These are molecules that deposit silica or glass on hot surfaces. It's going to cause damage to your engines or to your biogas stream. In water, you might want to remove pesticides or herbicides or compounds that cause taste and odor. Generally, these are big organic molecules, and they're ideally suited to be trapped in those pores. You can also use carbon to remove inorganic materials. Two important examples there: hydrogen sulfide, which is the primary contaminant in biogas. It's that odorous corrosive gas you find in biogas and other places too. Ammonia is another one. And with these inorganic molecules, they don't tend to stick too well to a standard carbon, but we treat this carbon surface with particular chemicals to target these impurities, and you promote a chemical reaction on the surface of the carbon. We refer to that as chemisorption. So it's actually doing chemistry on the surface rather than just adsorbing and desorbing an organic molecule. It's a very well-established technology. It has been around for decades, but we have R&D to try and move it forward all the time. It is often used with other technologies or techniques, quite often as a polishing filter at the end of a process. You might take out other things first and then use carbon as the final step before you either vent your gas to the air or put your water into a sewer. So for example, in odor control, a big odor control might have a big biofilter and then have a carbon as a final step. In water treatment, you have various steps to purify water. You might go through membranes or ozone, UV. So the activated carbon takes out taste, odor, and color, for example, the big organic molecules. But to kill the bugs, you need to treat with UV or ozone. To remove metal ions, you need membranes. So we don't consider these as competing technologies. It's all complementary technologies. And again, you need to talk to the experts to actually get the ideal combination of different technologies. So carbon comes in many different shapes and sizes. You may be familiar with these terms. The most common types are GAC, or granular activated carbon, powdered carbon, or PAC. You have extruded pellets. Typically, these are 4mm pellets. They're used mainly in gas phase applications. On the right-hand side there, you can see at the front is a large GAC, a large granular. Typically, you can use for liquid phase or increasingly for gas phase applications. It's basically cheaper to do a large granular than a manufactured pellet. So we tend to see the market going that way, and the 4mm pellets at the back, just to give people an image of what it is I'm talking about. Because if you haven't seen it, it's hard to visualize. The carbon can be either virgin or new material straight out of the coal mine or from the coconut plants, or it can be reactivated. It can be the standard grades or these impregnated versions that I mentioned before, and the various raw materials. So the key message here is that there is no one size fits all for activated carbon. We have hundreds. I think last checkup we had 300 grades on our own range. So you need to talk to us about your application, your treatment objective, your flow rates, what contaminants you're trying to remove. Are there any competing contaminants that might affect the efficiency? And we will help you design a system to optimize what it is you're trying to achieve. So that's what activated carbon is. I want to say quickly what activated carbon isn't, because we do get a lot of questions. It's not carbon black. It's not carbon capture. It's not biochar. It's not shredded tires. It's a very pure form of carbon which does a particular job. But I guarantee at this show we'll get lots asked about all those other things. I've told you what carbon is. Where is it used? Well, you typically find it, again, focusing mainly on the waste management sector, which I think is most interest to this audience. So when you're venting gas to the atmosphere, you're looking at odor control and VOC, volatile organic abatement, again, taking out hydrogen sulfide, ammonia, VOCs. And you may also see it as a biomethane off gas. If you look at wastewater treatment plants, you purify the gas to inject it, but you will have some off gas that does need purifying. So those are typical odor management type applications. The picture at the top right is our largest, we've got a high flow filter. It's, you can see by the side, it's got 80 centimetre inlet and outlet. It's pretty vast in a 30-foot container. That's a waste transfer station, and it takes a very high flow of very low contamination level, as opposed to a biogas filter where you have a sort of moderate flow but a very polluted gas, a real witch's brew of nasties in there. So we have different filters for different applications. So that's venting to the atmosphere. You may also want to clean up your process gas and do something with the process gas. The best example that everybody knows is biogas, where again you have typically hydrogen sulfide, which is acidic and corrosive, or siloxanes, which, as I say, deposit silica on your hot surfaces, either to protect your CHP engine, that's a combined heat and power. Again, I always explain my acronyms. Or if you're cleaning up at a biomethane standard to inject into the grid, you will need carbon to take out those impurities to leave yourself pure enough methane to do what you want to do with it. Another important sector relevant to this, and I've got some energy from waste plant producers here as well, is flue gas scrubbing. It's a very big market for us. We are market leaders in the UK in supplying. It's a very fine powder typically, and that's sprayed into the flue gas system of energy from waste, not allowed to use with incinerator, but energy from waste plants. And it typically takes out heavy metals, so your mercury, your dioxins, your furans, And it's the best available technology, the best available technique, BAT, for this industry. You'll see it used at all municipal plants and increasingly at biomass incinerators, particularly if they're waste wood, where you don't know, there could be creosote or other things on the wood. That will kick off some fairly nasty things in the air. So at waste biomass sites tends to use carbon as well. And the picture at the bottom, we tend to supply in bulk, so 20-ton bulk deliveries. That's at an energy from waste site somewhere in the UK. You probably recognise it by the blue stripe on the flue, so I can't say where that is. So those are gas phase, typical applications. It's also widely used in liquid phase. The main use is actually drinking water, but it's not relevant to this audience. So on the industrial side, we can effluent, remediation, leachate. So you've got a dirty water that you want to take out the organic impurities. So just a flavour of some of the applications where you'll see carbon. It makes our job interesting because there are literally, as we said, there are 600 applications for activated carbon. You're talking edible oil, you're talking about gold recovery, respirators, cigarette filters, all sorts of bizarre things that use a little bit of carbon to do the job that they need to do. So, we've told what carbon is, what it's used for, a little bit about my company, it's a bit of history. We've been around since 1990, so we celebrated our 30th birthday during lockdown, so no cakes and parties, unfortunately. In '99, we were acquired by the CPL Industries group. It's a big group that mainly does solid fuel, plus a few other things. So we became CPL Carbon Link. Later, we changed our name to CPL Activated Carbons because we basically need to tell people what it is we do. Nobody knows what a carbon link was, it doesn't mean anything. The rental of vessels has been an important part of our business for many years. So this is kind of a plug-and-play system. We deliver a vessel full of carbon, you put it into your process stream, and when the carbon is spent, we'll simply change out the vessel. That's a key part of our business model. We've been doing that since 2003. The other key thing that we do is recycle spent material. It's a very big investment. We have a facility at Immingham in North Lincolnshire, and we'll be doing amber, that's the industrial waste, since 2013. You can see how the business has grown from just selling carbon, being a carbon trader, to being more of a full service provider. In 2016, we acquired a company in Spain called Galacim. They're a carbon supplier. They also do some other water treatment chemicals. Their main areas are drinking water, edible oil, so olive oil, and a bit of flue gas. That's their main interests. We can see how we're trying to expand geographically as well as with our service offering. In 2017, we launched what's at the time, and I still think it still is, the largest mobile deep bed carbon filter on the market, the 30 cube aquasorber, principally designed for landfill gas. Again, you have a moderate flow of quite heavily contaminated gas. You need a deep bed of carbon to take out the contaminants. And there's the picture there is a site in the south of the UK with 3 of those in series. Also, one of our site service vans, so we can supply guys to site to help with installation and removal of carbon if that's required. So 2018 was a major year of expansion for us. We took our existing amber kiln and converted it to green so we could start competing in the drinking water sector, and we've been quite successful in that, winning some water contracts. And then we installed a brand new amber kiln, which was more than 3 times the size of the old one. So we're investing heavily on the assumption and belief that the market for reactivation, for recycling carbon, will grow dramatically. And I'll go into the reason for that a little bit later with my crystal ball future predictions slide. We also acquired a company called Icon. They're based in Chesterfield, an engineering company that manufacture these things for us. Prior to that, we outsourced everything, but to bring it in-house, we have control of design, quality, scheduling, priorities, and other things. It just works better for us to have that in-house. So that was a busy year, as you could tell, for us, again, part of our growth. The year later, in 2019, we didn't do it, but our ultimate owners acquired a second activated carbon company. They were called Oxbow. You may or may not know that name. They were changed immediately to Reay Activated Carbons. It's US-based, but they're very strong in Europe, in France and Benelux. So again, it suits us very well. We're strong in the UK and Spain, so to give us to France and Benelux allows us to organically grow into those sectors. It's not a true merger. We refer to them as a sister organisation, but it gives us benefits in terms of logistics, sourcing, and importantly, it allows us to grow our vessel service model into new markets. That's why the vessels are co-branded, because they could end up in the UK, could end up in France. We swap them around for maintenance and for where to go where they're needed. So technically it's not a merger, but it suits me as a marketing guy to have co-branding on them. And just to say, actually, because we are growing so rapidly, our revenues kind of increased about tenfold in the last 9 years. So we're growing very rapidly. We can hope that will continue. We are actually recruiting a new area sales manager. So if you're interested in that kind of sales role in our technical sector, then please come and talk to us on the stand. We'll be happy to talk to you. So what do we do? We're not the biggest carbon company, but we're very proud that we are the only UK-based carbon company that can offer all of these products and services. Obviously, we have a range of carbons which we sell under our FiltraCarb name. The impregnated grades, as I mentioned before, we manufacture a lot of those ourselves. Again, it gives us quality control and formulation control, and keep the secrets to ourselves. I've mentioned already the separate facilities for spent carbon. So you have the amber list waste, which is the biogas that we control, the remediation, you have industrial grades, and then the green list waste, which is principally for us drinking water. But you might also get carbon coming back from a beverage company or food grade activities. And that's important, of course. If you work for a water company, you want to know that your carbon hasn't been anywhere near a biogas carbon or an odor control carbon. So we have 2 separate buildings and have separate logistics flows and separate workwear for the guys and all that type of thing. So we've gone to a great deal of effort to optimise that. Mention the vessels. So we have in-house engineering, courtesy of our company in Chesterfield, called CPL Icon. So it's not just the design and build of the vessels itself, it's all the peripherals. We can design and install the pipework, the valves, the flanges, the supports, whatever you need to install carbon or to use carbon in your process, you can come to us. The example at the bottom right, I'll just quickly go through as a case study, is a wastewater treatment plant here in the West Midlands. They're using obviously the biogas off the wastewater, putting it through an engine to make electricity. They had a small fixed, there's a 2 cubic metre filter, quite small. It wasn't sufficient to take out the siloxanes and to cope with the flow. So they went all out and got our biggest filter, the 30 cuber, but it physically wasn't space to put it where the old filter had been. So we quickly designed and installed all the pipework you can see there. We did that in 2 weeks. So we could basically install safely in the correct position using our articulated truck, pictures of the truck, how we got this in here as well. So we can just plug it into the existing system. So we can supply that full service if that's required by customers. If a customer hasn't used carbon before, that might be a viable option. Where do you plug in the carbon into your process and how do you do it? I mentioned site services before. We're happy to help people install, remove the carbon or carbon filters. We have a team of guys go around the country doing that. And we have full laboratory backup, both in terms of quality assurance, to make sure our virgin and our regen carbon is of good quality, but also R&D. We're always looking ahead to new applications, new raw materials, process optimization, all those things. That's all done under the umbrella at Immingham, where we have our production facility. Makes sense to be there. And of course, we have the latest accreditation for quality, environments, and UK REACH. So, as I've alluded to, we aspire to be a one-stop shop for carbon requirements. If you need purification for your sector, your industry, your problem, come to us, talk to us, and we'll help you solve that. So a little bit more about reactivation, because that has been an important part of almost like the backbone of our business and our growth and our investments in recent years. So I showed you the pores of the carbon and filling up with impurities. At some point, you'll need to, that carbon will no longer be useful. You might see some breakthrough at the exit of the impurity. It's a little bit more complex than that, but essentially when the performance drops off, you want to start to think about regenerating the carbon. And the idea is you apply heat to it. We use a horizontal rotary kiln. It desorbs the contaminants. They're destroyed in the thermal oxidizer and various scrubbers. You're refreshing that carbon surface, the pores, so you can use it again and again, basically indefinitely, more or less. And that's what reactivation is in a nutshell. If you have a granular material or pellets, there might be some mechanical attrition. You might get a bit of powder coming off. We use the powder for other things like flue gas, but you can make up any losses in terms of volume or activity by adding virgin material if you need to. I've mentioned a couple of times this idea of 2 waste streams. That is critical. I keep banging on about it, but it is critical. And again, certain customers insist on that, and they will come and audit our site to make sure that using brand new bags, they're kept off the floor. There's no rodents. The guys have different workwear on to go into that plant. It is critical, and the fact that we can do both. And we started with a clean sheet when we designed these plants. How do we do carbon recycling better or a cleverer way? And I'll allude to mention some of those a bit later on, how we should do things differently. So why would you want to reactivate or recycle carbon? Why don't you use it and throw it away? That surely would be a lot easier. Principal advantage is economic. In most industrial applications, spent carbon is classified as hazardous, so therefore we need hazardous landfill or hazardous incineration, which costs a lot of money and is always increasing, so we can avoid that by recycling it. And the cost of virgin carbon is increasing dramatically. Anyone who uses carbon will be painfully aware of that. I mean, since the start of COVID, the spot price has gone up by about 50%, mainly driven by the well-known sea freight issue. A container that cost $2,000 a couple of years ago now costs $18,000 or $20,000 to get from China to the UK. That is a headwind we're all facing in our sector, but it favours recycling what you've got here already, basically. Buy a better carbon up front and use it again and again rather than buying virgin in. The second one is, of course, environmental. With our system, with our rotary kilns, we've calculated the carbon footprint is in excess of 90% compared to digging coal out of the ground, activating it and shipping it to Europe. Some competitors use a slightly lower figure than that, but they have brick-lined kilns that aren't quite as efficient. Our process is very, very efficient. You can switch the kiln on and off in 15, 20 minutes rather than 2 days. So there are big environmental footprints. And of course, you're not using up coal or coconut or wood by recycling what you've got already. People ask about performance. Well, for most applications, the performance of the carbon is maintained. And again, we will advise on that. We'll be honest with you and say, okay, for this particular contaminant in this stream, you really should be using a virgin carbon. But for everything else, it's really better to use reactivated. There are some cases where the regen carbon, as we call it, is actually better. The classic case is cyclic siloxanes and biogas. Because they're cyclic and quite big molecules, they tend to sit better in the pores of regenerated carbon, which is slightly opened up because of the regeneration process. Anyway, there's no concerns with using regen carbon in terms of reactivation. All the drinking water companies use regen carbon for that purpose. They're not concerned about it. They're more concerned about the purity and the traceability. So our philosophy is we will always regenerate carbon whenever possible or practical. We have a carbon acceptance procedure. We will take a sample of a spent material. What is on it? What level, are the levels too high for us to deal with it? Are there some unwanted contaminants like radioactive materials or a lot of halogens where we simply can't handle it? But we will tell you that. But wherever possible, generally speaking, for most applications, we will take it back. So I want to share, as I said before, we have R&D looking at improving processes all the time. On the gas phase side, we are particularly concerned what we call handling difficult carbons. That's a euphemism for much more difficult than that. These are heavily loaded carbons. You can imagine the pores being particularly loaded with things that are difficult to get off. The classic one is sulfur, which is an issue for the biogas sector. Traditionally, if you have more than 15% sulfur on your carbon, again, H2S is the primary contaminant, that's where the sulfur comes from, you simply can't regenerate it. As soon as you put heat on it, it basically coats elemental sulfur everywhere, or if there's any moisture present, it'll start corroding the sulfuric acid. So, yeah, sulfur is the enemy of the reactivation kiln. And what that means is, practically, is there's huge quantities of carbon out there being disposed of that we could get back to recycle. So, we want to get our hands on that. We have this huge kiln, one of the biggest in Europe, but we want to get our hands on that carbon. So we've just completed a successful R&D program looking at how to handle these difficult spent carbons. So we're now targeting a sulfur loading in excess of 40%, which is quite a significant jump. And that, as I said, opens the door to these carbons that are currently just being disposed of in hazardous landfills. And hot off the press, we have a new plant under construction at Immingham in order to handle these types of difficult carbons. So that's quite a new bit of information. On the liquid phase side, in order to compete and to gain advantage certainly on the drinking water side, we acid wash the spent carbon when it arrives before it goes in the kiln. But we use a hot acid wash. Nobody else does that. And it just basically removes mineralization, hardness, and some of the impurities before it gets anywhere near the kiln. So some people would do acid wash after the kiln, but then you're baking in the contaminants. By using a hot acid wash beforehand, you can remove lots of the metal salts. So by the time it gets to the kiln, the carbon is actually in very good condition. And then all you're doing is lifting up the activity level by putting it through a kiln. And we use purified water to remove that acid. So that's novel in our business, and it is allowing us to win a lot of volume on the potable water side. The business is always moving, and I wanted to share this slide with you, how I see the purification market going from now. A lot of the business, as you can imagine, is driven by clean water, clean air, renewable energy. Those things are always moving and developing. Back in 2019, the UK government launched the Clean Air Strategy. You may have heard of it. It's not new legislation as such, it's actually more of a roadmap to implement existing legislation. looking at 5 or 6 named contaminants, some of which aren't of interest to us as a carbon company, like particulates and NOx and SOx. We can't help with those, but we can help very much with VOCs, volatile organic compounds, and ammonia. So we believe there's potentially a lot of new activated carbon users out there that haven't considered carbon before, that may suddenly require carbon. The problem for me as a marketing guy is how to reach those people. They don't know that carbon is the solution to their problem. They may not even know they have a problem until the Environment Agency knock on their door and say, those VOCs that you've been permitted up to emit up until now, they've got to come down to essentially zero by the end of year X. So yeah, there will be more demand out there for carbon, but the challenge for our industry is how to reach those people. In terms of waste incineration, energy from waste, there was a BREF, that's a best available technology reference document published in December 2019, which set much lower standards in terms of mercury, dioxins and furans. They're the classic contaminants that you find in energy from waste plants. So again, we predict more use of perhaps higher quality powdered carbons in that sector going forwards. We're all aware of the desire to increase reliance on renewable energy, reduce reliance on fossil fuels. So the UK government launched the Green Gas Support Scheme last November, which should promote gas-to-grid biomethane. The uptake is quite slow so far, I believe, but it should drive the market in that direction. And also we believe there will be a market to convert the older biogas plants using biogas for electricity. The larger or the less efficient biogas plants may invest in gas upgrading to allow them to inject gas into the grid. So we think there'll be an opportunity there. We're members of the Reay, and that's definitely the new music we're getting from the Renewable Energy Association. Part of my job, I monitor imports of virgin carbon from everywhere into Europe. Like Europe as an island, and anything coming in is virgin carbon. So I basically add China, USA, Australia, India, Philippines, all those places that make carbon, and tot it up in terms of volume and price. So you can see it gives a rough snapshot of where the market is. The blue line is the volume. So there's a big kick up in the last half year. The volumes have gone up about 15-20% year on year. So there's more carbon coming into Europe. But look at the prices. The green is the average monthly spot price. It goes up and down with mix. The red line is sort of like an average 12-month rolling average. So since the start of COVID, the carbon price has gone up typically about 50%, and that's again mainly this issue of sea freight. It's just crippling the whole business. Clearly, the market for carbon is increasing for these reasons and others, but the cost is going up. So that's why we believe reactivation is the key way forward. Recycle what you've got now. Don't rely on virgin carbon coming in, because looking at that graph, it's only going in one direction. So before I go through the summary slide, just another quick case study. This is a biomethane site here in the UK. The OEM, the installer of the upgrading facility, included a couple of small biogas filters in their kit, a bit like the wastewater site I mentioned earlier. Was no way sufficient to cope with the flow and the contaminant level. They were having to change the carbon every 3 to 4 weeks, and that involved turning the gas off. So you only make money when you're injecting it. So they had to turn it off to change the carbon out. So they went with 2 of these 30 cubers, and we did all the pipe work as well, and we set it up so that they wouldn't have to turn the gas off. Keep the gas flowing, go through one filter, go through a second filter, and do a lead and lag system. So they're now changing out every 6 months rather than every 4 weeks. So it's a huge process improvement and a cost saving for them. It's just it's a nice clean site as well, so I always like to show that one. It always seems to be sunny there too, which is a bonus. So, my summary. So I've given you a quick overview of what activated carbon is and how it's used, particularly in the waste sector. So again, your odour control, your biogas, your flue gas, your VOCs, your water treatment, etc. For most applications, so not powder, we can't recycle powder, but most of your granular and your pellets, wherever possible, we recycle those with our facility. And we have a huge capacity as the business grows, which is expandable as well. My company, CPL Activated Carbons, we are the full service provider of the carbon, the regen, the vessels, the engineering, etc. And we've invested around £10 million in the last few years in this idea of recycling is best. But we're trying to even drive the market in that direction by being the biggest, down the path of regenerated carbon rather than virgin. And we've demonstrated the environmental and the economic benefits of going that route, and the fact there's no performance decline. I've also said that we are moving forwards all the time and explain the recent developments to improve the performance and the scope of reactivation in terms of handling the difficult gas phase carbons with sulfur and improving the performance of liquid phase carbons by this hot acid wash process that gives many benefits up front, and actually also when the carbon goes back to customers they can get back into service much quicker having gone through our process. So hopefully that was a good introduction. As I say, we're here for 2 days. Please come and talk to us. I'll put a very scary photo up now. Come and meet the team. I didn't know quite how close we'd be. I don't need to tell you where we are, because we're right there. But yeah, come and talk to us. If you have any questions about carbon or applications that you're thinking about, happy to take any questions with you. Good team in here for 2 days. So thank you very much for your attention. Thank you.